Yeah, guys. Just give me a wave if you can able to hear me or can able to see me. Just okay, cool. So we are here for a technical session on micro-ROS. So this we have every week Thursday we have on technical sessions. In order to give you an introduction about how technical stack will be during EVRC competitions. Cool. Yeah. So before moving towards the technical session, I feel we should have a look into the what exactly an EYRC competition is like. Why we are doing this, right? So main motto is to educate the students who are inspiring to start robotics as their career, and for that, I feel a competition will be a good way to start. Like, uh, yeah, you can do projects, but there should be a goal in your life. Like, if you set your goal as a competing with other participant national wide, then I guess with the goals, you can easily learn the aspect through project based learning. So here I'm to present you the introduction of what is EVRC competition. So basically, it's a more than 6 months competition, which we focus on project-based learning of in robotics. So we have multiple themes, which aligns with multiple tech stacks. For example, control system, drones, ROS, multi agents, FPGAs, and all. So basically, registration starts on August. uh, that's a 1 month registration. So minimum two people can be a team, and maximum four people can create a team. So I will suggest you can create your team in multidisciplinary branches. So it will be help for you, since some team requires mechanical, computer science background and all, right? So after the registration ends, so basically you have a chance to select your theme, or sometimes we usually give you a theme. Like, we usually ask your preference, like which tech stack you're interested to work on. Let's say I'm interested in drones, or I'm interested in multi-agent. So I can choose, like, okay, cool, I need to try drones this year. So you usually select your preference, and we usually assign it. After that, in stage one, it's all towards simulation. Like, first we will test your capability in solving the problems in simulation. Then we further move towards hardware. In simulation, basically, we give problem statement to you depending on the final expected outcome, how the bot should behave in the finale. So it will be divided in some tasks, and you have to complete it. And top performing teams, depending on the scores, and also we decide for stage two. In stage two, we ship hardware free to the students who are top performance in simulation task 2. So we usually ship the hardware. So they start working on the hardware. As you know, in simulation you have learned how to solve a problem, but apart from the problem, there will be hardware constraint to your bot. For example, you can't control, you can give a, usually motor has some particular speeds, right? After some speed it will not rotate. Like, sorry, after some speed you can't able to increase the speed. It has, this is a motor constraint. So we have some constraints of hardware. So with the help of, in order to make give light on that constraint also, you have to focus how to solve your problems with align with the hardware constraints and all. So usually built a bot in task 3. Then you usually kind of start working on the hardware, and till around task 6, the final task, which is the solution of the problem which we have given in initially. So on task 6, you will able to know what exactly the bot will do. Whole team, we usually call it the whole team, and what exactly bot will do in the finale. So depending on your performance, we usually select top 5 teams, which comes and showcase their solution in IIT Bombay. As you know, finale. It usually conducts on 2 days. So you will able to see all different region teams come together, and they showcase their solution, how they solved a same problem in different perspective and different views, and then we usually decide who are the most top performing team at that finale, and we usually give prizes and all. So uh, I will just go through the overall theme, but theme video you can see here. This is one of the theme which it's very interesting. Like you are working on real world manipulators with mobile robots. I feel it's visible, right? Yeah. So students usually remotely connect to this bot and work. Is one of the ROS2 based themes. This is if you're more towards an art side, you can choose this type of theme which focus more on art bots and all. Yeah, and this drone, those who are more into about drones and explore on drone themes, how drone works, drone kinematics, drone PI tuning works, and yeah. So there was a control system stack also. Basically, you are modeling a non-linear system. You usually linearize it, then you usually build a bot and control that. So this comes under the control system stack. And there was a functional programming theme also in past years. So these are all videos you are seeing done by the tier 2, tier 3 colleges, which were well motivated and can able to crack the problems which we usually gives during the themes. Uh, we usually gamified it in order to like they also need fun, right? To in order to do a solution. It's not be very. We feel engineering should be a fun and enjoyable way. So a problem statement I usually convert to it towards a gamified themes. So the prices you usually see are the certificate that is normal, that's from IIT Bombay, and the cash price and e-Yantra goodies you usually get. And that is an important thing which I feel uh, I usually align with like e-Yantra. Like we usually have an internship about the research. Like here we do research based internships on 8 week, which is a paid internship, plus like who all are top like finalist teams and top performing teams usually take interview. And they usually after interviews they usually come here at IIT Bombay. They works on research project which we usually float, and these projects we usually pipeline towards a research paper, and they usually publish a paper regarding that. This is one of the interesting part after EVRC. What with the help of this skill you are next aligned towards the research area, like what all research side you can see in your project, and how you can publish a paper and all usually happens on this 8 weeks internship. This is one of the main thing what I feel like it's very important for you, like in order to build your profile for placements and all. So yeah, so we can start. Yeah, in order to know more about the Yantra robotic competition, you can search on portal.e-yantra.org. You can get all information, the exact schedule, when it will happen, what all the uh, previous year themes, and by going towards the previous year theme, you will get some idea about what all tech stack you can uh, have a prep before the competition, and you can explore that. Cool. So now, I guess it's time for us to move towards the main agenda of this technical session, that is micro-ROS on microcontrollers. Okay, cool. So I guess in previous session you have heard about ROS2, right? So why ROS2? Basically, in order to uh, easily program the bot. Let's. I'm not concerned about the hardware. Like I'm a computer science student. This is one of the reasons, right? So I'm a computer science student. I want to know the how robot behaves in certain environment and certain algorithms. I can just simulate, and with the help of ROS2, I can easily set up the bot and easily do programming on that bot and get result on it. So, but yeah, so that's the reason. One of the reason for ROS2. But yeah, why micro ROS? So in order to know the answer, we'll proceed further. So the agenda of the meeting is will be, first I will introduce what is micro-ROS, and next why it is required, and next what all hardware and softwares are supported, and what is the, I will give you a rough micro-ROS architecture layer. Then I will suggest you to go on further and read about micro-ROS architecture layer, since it's a little bit vast. It's very vast. So after it, we will have a simple demo using ESP32 and a laptop, like using ROS node. I will create a ROS node and I will send the data to ASP32 and it will blink. So this is the overall agenda of this session today. So let's move on to the micro-ROS. Yeah. So what is micro-ROS? Basically, as I said, like with the help of ROS2, I can easily build a bot in simulation, and I can deploy in ARPi, some NVIDIA Jetson and all. But let's say I have some constraint about my budget, or let's say I want a simple bot which has ESP32, Arduino, or STM32. So if I want to if I want a communication from a laptop, that is a ROS node and the ESP. So there are different ways I can communicate. Like there is socket programming. I can use MQTT. I can sometimes use wire communication. But yeah, so there's another approach in which in all the approach, the main thing aspect which I miss is in previous approach is that I can send the data from point A to point B, but I can't able to use the concepts of ROS in that microcontroller. So let's say I want to create a service from there's server in microcontroller and there's a request, there's a client in laptop or a ROS node. So I can't able to create that. So micro-ROS is basically implementing a ROS2 concepts in microcontroller. So this has been developed in ROS1. There was similar stack which is called as Arduino serial, so which uses wired communication in order to send the data from laptop to microcontroller. But there were many problems in that, since there's a ROS core and all stuff. Micro-ROS has been developed in such a way that it overcomes all problems. Like I can use simpler publisher and subscribers, client and service, life cycles, parameters, and all into an embedded system edge device. So without knowing how to convert a data, how to what all the frequency rate of the data and all, I don't want to think about that and all. I will just write a code which will create a simple subscriber and publisher in ESP32 Arduino ID, and I can just connect the micro-ROS with the ROS, and I can get the data from ROS node to micro-ROS node. This is one of the main idea of what like made an idea of a micro-ROS. Like apart from the Arduino ID, like that's a bare metal support which has been given by developers. You can use it micro stack on free RTOS and different multiple RTOS such as Zypher and Netex and free RTOS. So why micro-ROS? So basically, as I said, it enables as a robotic developer, if I want to deploy some I have some constraint on hardware. If I want to deploy some algorithm, I can easily use basic microcontrollers, and I can test my code on that with the help of if I have a ROS communication network, I can use micro-ROS. First thing. Second thing is that there is a lack of common standard development framework which has been built by ROS community. Therefore, we should have a standard ROS communication standard architecture for microcontrollers also. So that's why micros has been created. Next thing is that, as I said, like if I'm using ROS, I can able to access the ROS2 packages debugging capabilities in microcontrollers. So these are the main reason why micro-ROS has been developed. Now, as you can see, it has been used by many industries also. One of the main open source platform which I liked using micro-ROS is Arduino Pilot. So they basically started using micro-ROS in their flight as drone developer knows. We usually use Mavlin to communicate between the Raspberry Pi. Let's say if you have Raspberry Pi and STM32 board like flight control, you usually use Mavlink and other stuff. But now ROS2 Autopilot has started using micros because they feel it is very you can easily access ROS2 nodes and you can easily get the data from the nodes. So this is one of the good applications which I have seen in recent days using Micro-ROS. So moving towards the hardware and RTOSs which has been used, one of the main thing, like as you know, nowadays we are using ESP32. It's a very standard which I feel should have Micros, and it has, and Raspberry Pi Pico. Teensy also had now, and Arduino Arduino Uno also has it, and STM32 is also, they also started supporting the Micro-ROS framework in their microcontroller. Uh, and what are RTOSs and bare metal? That's a different thing. Like RTOSs are free RTOSs, and Zypher and Etox has started using, like, they have Micro-ROS stacks, Micro-ROS stacks and all. And Arduino is a bare metal support. Like they have exactly a library which is in the GitHub also. So they are using. So if it's a channel library only, you have to just. I will show how to do the stuff. You have to just download the zip, and if you add it, you can easily use the functions used by using that library and create a code. So Arduino is one of the easiest way in to start working on Micros. The Arduino library for Micros. And let's move on towards the architecture of the Micros. So I hope that this the architecture of ROS2 has been familiar to some people here. So one of the I will just go through the overview of the ROS2 architecture. Basically, there is an application layer, and where you usually have algorithm and all stuff about that, and there's a client library where, let's say if you're using a publisher or subscriber stuff, so you are calling the functions of the library, right? So that all the exact logic behind that function has been written in the client library stuff stack. And there's a ROS middleware layer. So I will go on to for further slide. A rough idea about this, like you should have some set of instructions, like how publisher should publish, how subscriber and publisher should work, how topic should be named, and all structure has been structured and well written in ROS middleware layer. And there's a DDS. As you have familiar with ROS2, ROS2 works on DDS protocol. So it's one of the main reason why ROS core has been removed. Like it notes automatically detects other nodes. Let's say if I'm running one node and which is publishing something, and I'm running another node, the first node will automatically detect another node, and if topic is same, then it will directly start subscribe will start subscribing the publisher nodes ka data. So DDS. Then there's an OS which we usually use is Ubuntu, and there's an hardware, that is the laptop hardware which is they are mentioning. So similarly, what Macaros people have done, like initially they thought to use different architecture, but they after some iteration they thought like better to use a similar architecture of ROS2, so that the like they can easily use the code of that one thing. And since ROS2 developers are familiar with the ROS2 architecture, they can easily if they want to learn about Micro-ROS, and if I want to implement, and if you want to see if they want to debug something, so the architecture should be similar. If the architecture is similar, they can easily uh, uh, relate between the two architectures. So as you can see that CLC is one of the main library has been used here uh, for Micro-ROS, and there is similar to ROS middleware interface. Micro-ROS also have an RMW. I guess it's the below layer, it's mostly same only. The structure and all is same. The main difference in Micro-ROS is that the micro XRC DDS client. So actually, what exactly they have did is like they remove. It's similar to a DDS protocol only, but they actually remove the stuff which accumulates more memory to the controller. So this is a lighter version of DDS. That's why they call as micro XRCE-DDS client. So it's where you usually communicates the node. So there is an agent which you usually run on Micro-ROS. Sorry, you usually run on your laptop. So this agent is called as Micro-ROS agent. Which what it exactly do is it converts the data, that is DDS to XRCE-DDS. So here where the communication happens, the data will transfer. That is from as you publish some data towards ROS2, it goes towards DDS, and DDS say it went to Micro-ROS agent and it converts to the XRCE-DDS parameters, and that XRCE-DDS will then given to the client of Micro's XRCE-DDS. So this is how the communication goes, and how the data pipeline goes to XRCE-DDS clients. Then there is an real-time RTOS and other stuff similar to as an operating system used by as an operation used by a laptop. Similar to that, we have RTOSs and bare metal supports for microcontroller. So I guess this is the so one of the overall architecture of Micro-ROS, which I feel it's a good introduction to you. If you have anything, I will move on towards the explanation of that also. But if you have any, if you want to more explore on that, I will suggest go to the Micro-ROS webpage and look into it more on that. So yeah, as I said about the, we will now, I said about the Micro-ROS architecture, we will now see every layer. So basically, RCLC is where the fundamental ROS2 concept, as I said below above, fundamental ROS2 concepts such as publisher, subscriber, client service, and all stuffs usually is that like it's a library which has been created. Uh, mm, yeah, so there's an after RCL pi we move towards a middleware layer. There is a structures of layer which has been mentioned, and we are now into middleware layer. So middleware layer has a three stack. One is the ROS middleware interface, and another is the Micro-ROS XRC adapter, and there's another is the Micro XRC client. So middleware interface is what I said, like it has a uh, standard concepts such as how to there's some standard procedure for naming the endpoints, publish, subscribe, communication, client and service communication. All there's a standard concept has been written by RMV layer, and it's a very thin layer. After that, we usually have an adapter. Basically, this adapter has been created in such a way that this adapter is called Micro XRC EDS adapter. So what all the client gets data from the agent, this adapter will now then convert to the middleware interface. Why it's called an adapter? Like let's say if in future if I'm developing a good, let's say I'm developing another communication protocol apart from DDS, which can be communicated with ROS2. I can easily swap this Microsoft XRC client to another stuff. Yeah, but I need to change the agent also. Like I need to change the structure of the agent in a way that the DDS communication can easily convert it to the protocol which I have been created or have been developed, and then this client can be used. So the developers of Micros has been developed in a modular way so that any chunk you can easily remove and you can easily change it, so that in future if there is an another further development, you can easily use this modular architecture and change your way of communicating data in according to your stuff. So as I said, it translates the communication protocols so that the in the Micro-ROS language, so that the middleware layer can understand it, and then it goes towards the above side. This is the main reason of an adapter. And one of the thing of ROS middleware layer, that the concepts are provided not only by implementation of DDS standard, but also can be by any other middleware. As I said, like this is the main line which I have read, because you can easily change the middleware has been developed in such a way that you can easily change, like it's a layer which doesn't depend on the XRC client ka layer. Like you can easily change another you can easily put another protocol in that layer, and you can easily use it. That's why it's called as a modular architecture, and easy to develop it. And there's an XRC-DDS which has been developed by Prosima. So it comes and with micro, like it comes and with Micro-ROS agent which bridges with DDS, standard DDS and DDS XRC. So Prosima has been developed this Micro-ROS XRCE-DDS client, which can be used for microcontroller to get the data from DDS to micro XRCE-DDS client. So yeah, so basically, it supports multiple transports such as you can use serial UDP v4, UDP v6, TCP version 4, TCP version 6, and all. So in this example, we mostly focusing on serial. You can also explore on UDP, like multicast UDP. Usually, I have done with the help of Micro-ROS. So basically, I will have a hotspot which will have a single network which will in which laptop microcontroller and all be connected, and I will know the laptop. I will get the laptop IP address and put it into the ESP32. That's an code which has been asking the laptop IP address and the port number. Then if I run the Micros agent through Wi-Fi mode, I can easily transfer data from from laptop to the ESP32, and I can connect multiple ESP32 and create a multi ESP32 network with the help of this. So moving further, like as I in ROS, we have an operating system in this layer now. In microcontroller, it has an RTOS and bare metal Micro-ROS Arduino, where we usually write a code and all stuff is. So yeah. So basically, we have, as I said, we have an Blink example. Here we are going to use an bare metal approach of using an Micro-ROS Arduino. So it's an wrapper created by Arduino people, which enables publisher, subscriber, and services. You can use that concepts of ROS in with the help of Arduino code, and you can easily get the data from ROS node to the Arduino with the ESP32 or Arduino based board. And yeah, it uses the DDS XRC layer as an we are not focusing on the DDS XRC layer. We will directly focus on application logic, how to get the data, and what we can do with the logic. The backend has been taken care of by Micro-ROS Arduino. So moving towards demo. So basically the agenda of the this demo is like I will pass an integer after the basic publisher code. After the node publishes, node start publishing from 0 to 5. After 5, the LED should blink in the ESP2. This is the one of the logic which has been created. So I have created a GitHub repo for this. Like you can go through this repo, and if you like this repo, then give start to this repo. Or if you have any issues, or if you have anything to add on this for this technical session, you can add in this repo. So just give a PR to this repo. I will review it and accept it. So moving towards the technical session of this repo. So this repo, before moving towards the demo of the project, I hope that you in your laptop like don't start now. After the session, you can try this logic here. So I will be also sharing this repo on the chat so that you can try it on. Oh, chat is not available. Just a second. Okay, cool. I will share it when I will contact the team and share this report to you. So moving towards the repo, so prerequisite in your system should be first you should have ROS2 node, and I hope that Arduino IDE is installed, and Docker is also installed in your system. So there's a two way you can set up the Micro-ROS. One of the way is that you have to set up from source, like you have to clone the repo, and then you have to set up. There's some instruction which has been given by the Micro-ROS team, so you have to use that, and then you have to set up it. Otherwise, there's another way. They have created Docker image, so just install Docker in your system and you can easily proceed further. So first we will move towards the you go to the web and directly search for Micro-ROS Arduino. Sorry, Micro-ROS Arduino. So first that will be in GitHub. So here, if you see, every distribution, every versions of the ROS has different branches here. So we have an Humble branch. You have to go towards here because I'm using Humble here. So Humble is a which supports Ubuntu 22. So I'm using Humble here, and it's an LTS of ROS. So here, if you go below, you can see that you can use Micro-ROS agent with the help of Docker agent, or else you can use of obey the official, follow the official documentation of Micro-ROS, and you can set up your Micro-ROS Arduino stack. So here, what I'm planning to do is directly I will download the zip, and after downloading the zip, you have to wait for some time in order to download it. Then you can move towards your Arduino file, uh, Arduino IDE. So there, if you go to Sketch, this is a setup. This is a setup for micro-ROS in Arduino IDE. Include library and add a zip library. So that's, if you go towards that and you have to click go to downloads and you have to click micro-ROS, you will able to it will download your library and you can proceed further. For now, I have done that for you. Then there is an I hope that since ROS2 is in your ROS2 humble version is in your system, you have to just clone this repo. Inside this repo, you will have just a minute. Uh, Inside this repo, you have to rename, after cloning. You have to rename to you have to create a workspace, clone it, and you have to rename that folder to SRC. Inside the repo, you have two codes. One is the Arduino micro-ROS code, which I will be showing you, and another code is the publisher code, which has been created and given in this repo. So first we will move towards the uh, Arduino code. Since I hope that since you have attended ROS2 session, the publisher code, I will just show it. I will not explain what exactly happening in that code. So go to the file, open, yeah. So it's there here only. So so basically, it's a very straightforward stuff. You have to when you open the examples, you can get an you can explore how publisher has been made, how subscriber has been made, and all. So with the help of that, you can able to relate what exactly happening here. So yeah, so basically we initialize the libraries and all. You can directly take from the example code. Then we usually move towards initializing the objects of every part we are using, subscriber, executor, support, allocator, and all. uh, then we move towards the defining the error loop, soft check, hard check, and all stuff. We usually do that in order, if error is there, then you will if some error happens, then you will directly hold on to the it will not proceed further. Then you have just a minute. I guess I need to sub micro side. Okay, I haven't opened the correct code, I guess. Mm, Micro-ROS workspace. Yes. So yeah, this is the code. So yeah. So as I said, here everything is similar only. So if any issues is there, then you have to the ESP will be waiting in the while loop. Okay, so there's a subscription callback. As you know, since this node is subscribing, so as I said, like I will give an integer from publisher, one from starting from 0. After 5, the LED will blink it. So this is a logic which have been written here. So that's a, that side is a publisher, this side is a subscriber. So there's a subscription callback, right? So in that you usually define the message type, what is the message and all. Then you usually assign that message to message or data. After message or data, we will move towards the setup part, where this is the main stuff which I was you want to look into. This is a set micro-ROS transport. I guess it is visible. The code is visible, right? I hope. Yeah, I have just increased the size. So here, for serial communication, you are using this micro-ROS transport. It's a method which has been used. So if you want to use an wireless communication, uh, there is an example which has been mentioned here. Just a second. So I'm just opening in sub publisher Wi-Fi stuff in order to show you how, if you want to use an subscriber and if you want to do wireless communication, so you want to just write micro-ROS Wi-Fi transport, Wi-Fi SSID, password, the laptop ka IP address and port number. So this is all stuff you have to write. If you just do this, and if you need to check in your hotspot whether the ESP has been connected and laptop has been connected. If everything is connected, then if you have just run the micro-ROS agent in order to convert data from DDS to XRCE-DDS, and you're on go to communicate data wirelessly also. In this logic, I'm using a serial communication. And we are assigning allocator. Basically, allocator is for memory management stuff, like has been used by RCL, since it has a resource constraint. Microcontroller is a resource constraint device. You have to manage your memory, right? So that's why allocator has been used. And there is an uh, initially, if you want, this is for checking whether allocator works or not, initializing that, creating a node using initial node default. That's a subscriber, creating a subscriber. So topic is integer, and message type is std message and message int32. So then there is an executor, and I'm adding subscription towards executor call, subscription callback to an executors. And executor usually in ROS, executor usually as executes the data from, let's say, it usually handles the callback functions and all that. So we will proceed with spinning that executor. Sorry. So if message data is in the loop, I have given the logic that if message data is greater than 5, then blink LED, else blink LED loop. So I will be using ESP32. I guess it has been visible. Yeah, cool. So just a minute. Oh, this is, yeah, cool. It's visible. Cool. So here I have uploaded the code. I can upload the code now also. I'm uploading the code. While uploading, we can proceed with. I've opened micro-ROS in. I'm opening VS Code here. So it will be uploaded. Till then, I can explain you what exactly in publisher. Yeah. Here you can see that in publisher.py has been written. Skin, you need to. Yeah, good. So here, it's just pretty straightforward, I feel. You are just initializing the libraries, creating a class. You are just creating a node and assigning the publisher. After 0.2 second, the timer will, there's a timer callback. After 0.5 second, the message will be published again. So inside timer callback, I have assigned message data and all, and I have said that after this, after publishing one data, you have to just add add it to, like, add it to one, like after 0 it will go to 1 2 3 after 0.5 seconds, and then I have just mentioned in minimal indef main. Yeah, I guess the code has been uploaded. uh, After cloning that, you have to create src folder. Inside src folder, this all content should be there. uh, Ignore build and install. Inside src content, the contents of the github code should be there. And then you have to do callcon build. After building it, you can proceed with ROS to run. mm, Package name, and if you do tab, there will be Docker. Before that, I will just connect the Micros. I will just run the Macros or Macros is in another terminal, and it will ask password for me. So yeah, I'm using Docker. So after that, you have to, after running it, you have to press this EN button. There's an EN button and boot button here. Enable button and boot button here. I would just press it. So after pressing it, the data has been Micros has been sorry, agent has been detected the microcontroller. Now data can be passed transfer from ROS to node to microcontroller. Yeah, I'm starting the talker node. As you can see now, LED is not blinking, but after 5, it should just okay. Just a minute. I will check in. Oh, it's not connected. Okay, it's not connected yet. Mm, just check the code once. No, it's not subscribing. Yeah, I'm uploading it again. I guess the data hasn't connected. Yeah, just a minute. Subscriber node allocator. Cool. Yeah, I'm again uploading it and we'll check. Yeah, cool. Now if I run this, and I need to check. I will check in Arctic QT whether the node has been detected. Okay, wife subscriber node is already active. Oh, might be. Okay. So the port number is USB 0 only. Mm, yeah. So agent has been connected, but the yeah. So I'm looking into it. Before that, if you have any doubt, you can just ping me here. We can put in the chat. We can discuss regarding that. Oh, chat has been. Good. Yeah, you can have the questions. You can have questions on that. Anything. Okay, cool. Regarding the okay, the question from yeah, Prathamesh was, what is the scalability and application based case study example of Micro-ROS? So scalability and of Micro-ROS stack is since it's in development stage, I feel that I have been used this for more than 3 bots. I guess it has no purpose and stuffs, other stuffs. Industries, I have little doubt how it will be managing stuff. Mohammed has a question that how do I flash macros firmware onto my microcontroller? So Mohammed, as I said you that you have to go towards ESP32. Sorry, you have to go towards Arduino IDE, connect your Arduino IDE, and there is an ESP32. It's net is working. Is it lagging or? I'm audible, right? You can able to see my screen, right? Just I will check the sharing session. Yeah, screen is visible, right? Yeah. So as I said, you have to include your library here, and screen is shared, I guess. Showing shared. It's okay. Mm, So how to flash micro-ROS firmware, right? First question according to that Mohammed was like you have to go to Arduino IDE. It's a simple process. You have to include your library and just click on to the upload. Then you can easily connect ESR2 and upload your firmware. Uh, what are some of the key parts of using Arduino for micro-ROS? Key part instance, what I feel, it's a easy way to start your developing stuff. That is, like you can easily understand the code, and yeah, you can either use platform ID also or RTOS also. So main reason for Arduino ID is like fresh, easy to start and easy to deploy your code and check once. What is the main difference between micro? There's no micro-ROS one actually. There is micro-ROS has been developed for ROS2 purpose only. So Sai, there's no micro-ROS for ROS 1, and main difference between ROS 1 and ROS 2 is that ROS 2 you can easily, if any node comes between the uh, if any node comes during the operation, you can easily the DDS can easily detect and easily communicate with that. But in ROS 1, what exactly happen if main node crashes, you can't able to do that stuff. Communication is not possible. How to download? Ankit has a question like how to download a supported version of Ubuntu 22 LTS for ROS2. Uh, if you go towards yeah, so Ankit, if you explore on Ubuntu 22 LTS, you if you download Ubuntu LTS, you have to just go to ROS2 Humble and do the installation process. Yeah. Sanjeev, can we run ROS 1 and ROS 2 node together? Yeah, there is a bridge which you can use ROS 1 and in order to communicate between ROS 1 and ROS 2 node. You can easily do that. Khan asks how you can synchronize multiple microcontroller in distributed ROS 2 system. Synchronizing, according to my experience, like. mm, yeah. So that's that's any other way I don't know. But using this biometric support, if I'm not wrong, there's no synchronization like uh, the bots. Like if you want to get the data from one microcontroller to another microcontroller, you can do that. And I guess synchronization happens in backend. In RTOS and all, I need to check what exactly happens there. How does Micros integrate with ROS2? So basically, it has an bridge. So as you know, ROS works on DDS. So it has a bridge. There's a Micro-ROS agent which acts as a bridge between ROS2 and Micro-ROS, that is DDS and micro XRCE-DDS. So from that, the message has been converted and sent. So what is the alternative? Sai asks, what is the alternative of micros? Can we make communication between ESP and Raspberry without it? Yeah, Sai, you can use standard. Uh, if you want to use ROS, then you can either proceed with MQTT protocols or socket programmings, which is available. But MQTT doesn't have latency, but socket, I guess, it has a latency issues and all. Harshita, regarding certificates, you can mail to helpdesk@ifn.org and you can get data. How Microsoft is using collaborative multi-robot system? Yeah, so this is a good question which raising us. So basically, there was a theme which has been used Micro-ROS past years. So we have used like there's a centralized system, and we usually give tasks to multiple bots. And yeah, so you Micro-ROS is just a layer which you usually send the data from ROS to nodes to microcontroller. Right. So this is a layer which you can use in since DDS is supported in distribution system. XRC DDS also supports in distributing control of a system. So how do we integrate motor controller IMV with ROS2 via Microsoft? So basically, what exactly you can do, Khan, is you connect your IMU and motor with ESP32 and do processing there. Like if you have an IMU, do processing there. And if you want to have after processing, you will get roll pitch here or X and Y from IMU, right? You just publish the data in Publisher. There is an example here which explains you how Publisher works. So you can use that and you can publish the data. You subscribe, use Micro-ROS agent, run the Micro-ROS agent in this host system, subscribe it to the subscribe it to the there's a create a Python code which will subscribe this data and you will get easily the data. And if you want to control the motor also, you do like this, like publish data from the ROS2 node and subscribe to microcontroller and run the node. How we minimize the, so basically you don't want to do anything, since micros take care of everything about the memory stuffs. And micros, I know bare metal has a backend stuff which usually take, that's allocator, which takes care of memory stuffs and all. So you just work on your logic and you can proceed further. So certificate and all will be mentioned in. So Prathamesh, DDS and XRC communication, in broader terms, it's DDS called data distribution service. So like I haven't explored too much depth in it, but yeah, I can come after. Like if you have any doubt, you just mail me. We can discuss regarding that. So basically, it actually checks whether all nodes are present in the same network or wired communication, and it send the data. So I guess the quiz has been started. You can check the quiz link. Quiz has not started. Sorry. Oh, sorry. So let's move on towards the quiz section. Before that, there's a next talk on 19 July. If you want to register that, you can register on e-Yantra talks, and quiz will be sent in the chat. You can go towards the quiz, and you have 5 minutes. It will be in the chat within some minutes. Yeah, so you can. Uh, there's a link which has been sent here. You can just go towards and mm, do submit your quiz. So you can mail at helpdesk@eifund.org, Prathamesh. We can talk if you have any doubt. We can go towards that.